Hello dear students, good evening to each and everyone. All of you are welcome back on Wallah English channel. We are studying signals and system in comprehensive manner. Already we completed total 19 lectures and this is lecture number 20. In this class, I will teach you how to calculate RMS value and average power, or we can say power of a continuous time signal and discrete time signal. First of all, tell me, audio and video both are clear to you people? Am I audible properly? Okay, shall we start? Audio and video both are clear to you people? Okay. So calculation of energy we completed. Now in this class we will study how to calculate power and RMS value also. So title is calculation of energy, power and RMS value. In that we will see the calculation of power and RMS value. Okay. Now see, if you integrate any signal, whether it is periodic or aperiodic, if you integrate any signal from minus infinite to plus infinite, number one, if you integrate any signal from minus infinite to plus infinite, x of t dt, then what is the meaning of this integration from minus infinite to plus infinite? So simply if you integrate any signal from minus infinite to plus infinite, then this is known as total area of x of t. We can say total area of the signal x of t, continuous time signal x of t. Now suppose if x of t is periodic, if x of t is periodic signal, then if you integrate this periodic signal over a fundamental time period, if you integrate this periodic signal over a fundamental time period, then this is known as area of x of t for one cycle or over a fundamental time period. This is area for one cycle or area of one cycle or area under x of t over a fundamental time period, correct? So I can write here area of x of t over a fundamental time period. Over a fundamental time period, correct? Now then next, if you divide this integration divided by fundamental time period by capital T, 1 by t into integration of x of t over a fundamental time period, then this is known as what? Average value or DC value or mean value. Okay, this is known as average value, DC value or mean value. So it is nothing but average value of x of t, area of x of t over a fundamental time period divided by fundamental time period. So it is known as average value, or we can say mean value, or we can say DC value. Clear? Average value, mean value, or it is also known as the DC value, guys. Now same integration but after squaring of x of t, then it is known as the mean square value or average power. number 4, 1 by t integration over a fundamental time period after squaring first square of x of t dt. Then you can see here, this is known as what, guys? This is mean value of x of t, and this is known as mean square value of x of t, guys. Mean square value, and it is also known as average power. It is also known as average power of x of t. Correct? X of t is the periodic signal. Average power of x of t signal. Correct? And if you do the square root of this term, then it is known as root mean square value, RMS value. Here, next, fifth number, under root under root 1 by t integration over a fundamental time period x square of t dt. Correct? X square of t dt. Okay, so this is known as what? Square root of mean square, that is the RMS value. RMS value of x of t. RMS value of x of t, or we can say under root of average power of x of t. Correct? Square root of average power of x of t. Clear? So this is very, very, very much important, guys. See, again, simple integration from minus infinity to plus infinity, it is known as the total area of x of t. Integration over a fundamental time period, that is known as area of x of t of one cycle or over a fundamental time period, and divided by capital T, then it is known as average value or mean value or DC value. And after taking the square, if you integrate, then it becomes the mean square value. Okay, this is mean square, not mean value. This is mean square value. Mean square value or average value, we can say. Mean square value, or it is known as the average power. Mean square value, or we can say average power of x of t. Clear? Fine? Okay. Now next, guys. Now let us see the formula for the power. Okay, power is nothing but what? Energy per unit time. So first, x of t is periodic signal with fundamental time period capital T. If it is a periodic signal, then its average power for the periodic signal, its average power is given by 1 by t integration over a fundamental time period. Again, if it is a complex value signal, then you have to take modulus, magnitude, mod x of t whole square dt. Okay, so here simply you can see this is the formula of energy over a fundamental time. If you observe this one, guys, if it x of t is periodic, then this term is nothing but what? This term is nothing but, we can say this here, this term is nothing but energy of x of t for one cycle. Energy of x of t for one cycle, or energy of x of t of one cycle. Correct? Okay, divided by fundamental time period. So if you want to calculate average power of periodic signal, then simply you have to find the energy for one cycle of a periodic signal divided by fundamental time period. So it gives average power. It is also known as mean square value. And if you take the square root of this mean square value or average power, then it becomes the RMS value. Okay. And second, suppose if x of t is aperiodic. So what is the fundamental time period of aperiodic signal? So fundamental time period of aperiodic signal is of course infinite. Correct? Of course infinite. So if x of t is aperiodic signal, if it is a aperiodic signal, x of t is a aperiodic signal, then the average power is given by, as I told, guys, the fundamental time period of aperiodic signal is infinite. So that's why limit t tends to infinite. Now integration from minus t to plus t for simplicity. So as minus t to plus t, so here divided by 2t guys total. Suppose 0 to t, then 1 by t. Minus 2t to plus 2t, 1 by 4t. Again mod x of t square dt. This is the formula to calculate power of a aperiodic signal. Clear? Similarly for the discrete time signal also, suppose x of n is a discrete time signal, discrete time periodic signal of fundamental time period. Capital N, then it's a average power is given by fundamental time period is capital N. Instead of integration, now summation will come into picture. Mod x of n whole square. Here n is equal to 0. 0, we are starting from 0, so that's why here n is equal to what? N minus 1. Suppose the fundamental time period is 5 guys, correct? Then summation will be what? N is from 0 to 4, then and then 5 guys. N equal to 0, n equal to 1, n equal to 2, n equal to 3, and n equal to 4 guys. So 0 to 4, total 5 samples will come into picture. So that's why if fundamental time period is capital N, then 0 to n minus 1. Clear? Okay, very good. Very good guys. And this is for the periodic signal. Suppose x of n is aperiodic. Suppose x of n is aperiodic signal. X of n is aperiodic signal. If it is aperiodic, then again fundamental time period of aperiodic signal is always infinite. So that's why average power is given by limit n tends to infinite. Now again instead of integration, here summation, here minus t to plus t. So here it is minus n to plus n, mod x of n square. Now minus n to plus n, total number of samples. Tell me total number of samples from minus n to plus n. Suppose if you are doing the summation from minus 3 to plus 3, then how many samples guys? Calculate minus 3 to plus 3. Minus 3 minus 2 minus 1. 0, 1, 2, 3. Total 7 samples will come into picture. Minus 3 to plus 3, 7 samples. So you can write 2 into 3 plus 1, which is equal to 7 samples. Correct? So if it is minus n to plus n, so compare with this, then it become what? 2n plus 1. 2n plus 1. Clear? So these are the formulas to calculate power of a periodic signal, aperiodic signal for the continuous time as well as for the discrete time guys. Okay. Now observation for the periodic signal. As I told you, this is nothing but energy of x of t for one cycle. So here if you want to calculate average power of a periodic signal, then what is the shortcut? The standard formula is 1 by t integration over a fundamental time period mod x of t whole square dt. Okay. So here this is nothing but this formula is, this is what? Energy of x of t, energy of, this is energy of x of t for one cycle or over a fundamental time period. For one cycle, energy of one cycle of x of t, correct? So here average power, shortcut is you have to calculate energy of one cycle. So energy of x of t for one cycle or over a fundamental time period, for one cycle divided by capital T, simple formula, correct? And if you want to calculate RMS value, then RMS value is nothing but what? Square root of this one, square root of average power, square root of average power. Clear? So here it is energy of x of t for one cycle, and this is in this is under root, correct? So under root of energy of x of t for one cycle or over a fundamental time period divided by fundamental time period. Clear? This is the shortcut. Any doubt in this formula? Clear to each and everyone? Done? Any doubt, guys? I hope all of you are getting correct. Now let us solve some questions based on these formulas. Okay, so let us start with the first question. Let us calculate energy of a sinusoidal function a sin omega t or a cos omega t or a sin omega t plus 5. Okay, so let us consider a sinusoidal signal x of t is equal to a sin omega t. Okay, and we want to calculate power of this sinusoidal signal. So the average power is given by, as this is sinusoidal function is a periodic signal, guys. As this is the periodic signal, what will be the average power? So 1 by t integration over a fundamental time period. As this is a real value signal, need not require to take modulus x square of t dt. So the average power is given by 1 upon fundamental time period integration over a fundamental time period square means a square sin square omega t and different integration with respect to t. Sin square theta equal to 1 minus cos 2 theta divided by 2. One upon capital T integration over fundamental ampere a square 1 minus cos 2 omega t divided by 2 dt, correct? 1 by t integration over a fundamental ampere a square by 2 dt minus 1 by t integration over a fundamental ampere cos 2 omega t divided by capital T dt. Now here tell me, guys, what is the answer of second integration? What is the answer of second integration? This integration indicates area of cos 2 omega t over a fundamental ampere. So what is the area of cos function over a fundamental ampere, whatever the frequency it is, correct? What is the area, guys? Tell me. The area of second integral over a fundamental ampere or area of cos 2 omega t over a fundamental ampere. So it is 0 because area of positive half cycle is equal to area of negative half cycle. So total area becomes 0, correct? Total area becomes 0. So that's why answer of second integral is always 0. Always 0. So the average power is given by here 1 by t, this is a square by 2, and here integration is t 0 to t, guys. Over a fundamental ampere means 0 to t, so 2t get cancelled out, so a square by 2. So power of a sinusoidal function is what? A square by 2, guys. Final answer, average power of sinusoidal function peak value square divided by 2. A is the peak value. Clear? Now instead of sine, suppose if it is cos, guys, replace sine with cos. Is there any change in answer? No. If you replace sine with cos, then here sin cos square omega t, it becomes 1 plus cos 2 omega t. Then final answer remains same, correct? If you add the additional phase, so additional phase angle doesn't alter power of the given signal, correct? Additional phase angle also. So what exactly I am saying, guys, whether it is a sin omega t, a cos omega t, or a sin omega t plus 5 or a cos omega t plus 5, what is the average power of any sinusoidal function? The average power of any sinusoidal function is given by peak value square, whether peak value positive negative remains same, peak value square divided by 2. Clear to each and everyone? So the average power of any sinusoidal function, power doesn't power not depends on, power does not depends on what? The frequency, phase angle and time. Simply depends on what? Amplitude of the given signal, or peak value of the sinusoidal function, or peak value of the given signal. Energy is directly proportional to square of the amplitude, and it is directly proportional to width of the given signal. But here you can see the power is directly proportional to square of the amplitude only, correct? And already we have seen energy is directly proportional to square of the amplitude and it is directly proportional to width of the given signal. So here time shifting, time reversal operation doesn't alter energy of the given signal as well as power of the given signal, but time scaling operation can change width of the given signal, hence there is a change in energy. But time scaling operation doesn't alter power of the given signal, because power is completely depends on amplitude only, not depends on the width. Okay, remember this thing. So time scaling, time shifting, time reversal operation doesn't alter power of the given signal. Any doubt in this? Any doubt, guys? Clear to each and every student? So this is very much important concept, guys. And we found the power of sinusoidal function by the standard method formula. Now with concept, see, now first of all we will find the power of periodic signal, whether it is sinusoidal or non-sinusoidal. First we will find the power of periodic signal, and then later we will find the power of aperiodic signal also. So this is the simple periodic signal, square wave, and we want to calculate power of this. So need not require to use formula. I already told you how to calculate the power of this signal. Then energy of x of t over a fundamental ampere. Find the energy of this x of t for one cycle divided by fundamental ampere. So first we will find the average value or DC value or mean value. Then we will find the average power. Then we will find the RMS value also and total energy also, guys. Okay. So let me calculate first average value or DC value, average value or DC value or mean value, or we can say mean value, correct? Average value or DC value or mean value. Tell me how to calculate average value or DC value or mean value. So area of one cycle divided by fundamental time period. Average value of x of t is given by, it is nothing but what? Area of x of t according to the formula 1 by t integration over a fundamental time period x of t dt. So this is nothing but area of x of t, area of x of t over a ft means fundamental time period divided by fundamental time period. So tell me the total area. So calculate area of positive half cycle and area of negative half cycle. So area of positive half cycle is nothing but a into width t by 2, and area of negative half cycle is minus a into t by 2. So what is the total area? Total area becomes 0, because the area of positive half cycle and negative half cycle both are same but opposite in sign. That's why the average value is, area of positive half cycle is a into t by 2 plus area of negative half cycle is minus a into t by 2 divided by the fundamental time period. So average value is 0. Here average value is 0, guys. Clear? Fine. I hope all the students are getting. Average value is 0. Now next we want to calculate average power, guys. Average power. Okay. So average power is given by, already I told you, for the periodic signal, energy of x of t of one cycle divided by fundamental time period. So fundamental time period is capital T. Here you can see, guys. See, this is the first cycle. This is the second cycle, and then so on, guys. Okay, so from here to here we can say fundamental time period, or we can say from here minus t by 2 to plus t by 2, this is also fundamental time period. Negative up cycle, positive up cycle, this is also negative up cycle. So what is the energy of one cycle? So this is the one cycle, guys, this one. Okay, so here this is one cycle, or we can say this one, this is one cycle, correct? Okay, or you can say this is one cycle. You have to find energy of this one cycle, energy of this rectangle pulse, a square into width divided by 2. So a square into width divided by, sorry, a square into width only, energy of rectangle function, a square into width, a square into width is t by 2, t by 2. What is the energy of this? So again a square into width, a square into width, clear? So the total energy is sum of individual signal. Total energy is a square into t by 2 plus a square into t by 2 divided by fundamental time period is capital T. So it will be, this is a square into t, t get cancel out, a square. So average power of this square waveform is nothing but a square. A square, guys, this is a, this is minus a square, simple. And if you want to calculate RMS value, then what will be the RMS value? The RMS value is nothing but what? Square root of average power. Square root of average power. So square root of a square, RMS value is a. Now tell me, energy of one cycle is finite, which is nothing but a square into t. What is the energy, total energy of this signal? Energy of one cycle is finite, and there are infinite number of cycles are there. So total energy will be what? Infinite. Total energy is infinite, guys. So number 4, total energy. What is the total energy? So total energy is equal to what? Infinite, guys. Clear? Okay. So in this way we can calculate the average value or DC or mean value, average power, RMS value, and the total energy of the periodic signal. Is this clear to each and everyone? Tell me in the comment box. Now audible? Audible now? Okay. Okay. Audible है ना? Properly audible now. Okay, great. So RMS value is what? A by root 3. And this the average power is a square by 3. What is the total energy? Can you tell me the total energy of this periodic signal? In previous also, this was a periodic, this is the periodic signal. So energy of periodic signal is always infinite, or we can say power is finite, then energy will be infinite in each and every case. Here power is finite and we got the energy infinite. All the periodic signals are always power signal, that's why power remains finite and the energy will be infinite, guys. Remember this thing. That conclusion also I will tell you. This is also periodic signal and it's a power signal, and energy is infinite. If power is finite, then energy will be infinite. Here also energy of one cycle is finite, so there are infinite number of cycles. So total energy of x of t will be infinite. Clear? All of you try this question and tell me the right answer. This is also periodic signal. So I told you guys, each and every periodic signal is always power signals, and you will get finite power for periodic signal and infinite energy. The energy will be infinite. So tell me the average value will be 0 or non-zero. Average value will be 0 or non-zero. Tell me the average value, or mean value or DC value. Non-zero. Okay. If it is non-zero, then tell me the value of DC or average value or DC value or mean value. So area of x of t over a fundamental time period divided by fundamental time period. Find the area of x of t of a over a fundamental time period. What is the area? So from here to here, this is the fundamental time period, correct? Capital T. This is the fundamental time period. So what is the fundamental time period? Fundamental time period is 2, and we want to calculate area of this triangle. So area of triangle is given by 1 by 2 into base is 2 into height is 3 divided by fundamental time period is 2. Clear? So it will be 1.5. average value is 1.5. Correct. Now tell me the average power. Average power. The average power is given by energy of x of t of a one cycle of an one cycle divided by the fundamental time period capital T. So average power is given by energy. So what is energy here? Energy will be what? Energy of triangle, peak value square into width divided by 3. So 3 square into width is 2 divided by 3. So it is 6 joule. So this is energy is 6 divided by fundamental time period. Correct? Divided by fundamental time period is 2. So average power is 3. If you want to write unit, then unit of power is watt. Clear? Is this clear? 3 watt average power. What is the RMS value? If we calculate RMS value, the square root of average power, square root of average power, so it is root of 3, that is root 3, 1.71, and total energy, so it is periodic signal, so there are infinite number of cycles, and energy of one cycle is finite, so total energy will be infinite. So total energy is infinite. Again you can see this is also periodic signal, and we got the finite power and infinite energy. So again we can say each and every periodic signal is always power signal. Power will be finite and energy will be infinite. So energy of power signal is always infinite. Energy of power signal is always infinite. If it signal is if the signal is power signal, then power will be finite and energy will be infinite. This is the very much important conclusion. Okay. Very good. Now next question. Try this one. Okay. Already we solved this question, guys. If you can remember, already we completed this question. It's a very much important. Here, find power of the following signals. The average value will be 0 or non-zero. Average value is 0 or non-zero. Tell me. Average value is 0 or non-zero in the comment box. Tell me. Okay. So here average is non-zero. Why non-zero? Because only positive half cycle. Negative half cycle area is 0, but positive half cycle is there. So average value is non-zero. So first average value. Average value, or we can say DC value. So here average value is given by total area. So find the area of this. See, what is the fundamental time period? Fundamental time period means from here to here. This is the one cycle, guys. Okay, this is one cycle. So fundamental time period is from 0 to 4. The fundamental time period is 4, not 3. Not 3, guys. This is the one cycle. What is the total area? Area, guys. If you want to calculate the area, then here you can calculate the area of this triangle, area of this rectangle, area of this rectangle function. So total area is, what is the total area? So area of this triangle function, 1 by 2 into base is 1 into height 1, plus area of this rectangle function, height into width, so it is 1 into 1, plus area of this rectangle function, so it is 3 into 1 divided by fundamental time period is 4. So this is 1 by 2, that is 0.5, plus this is 1 plus 3 divided by 4. So what is the total average value? So this is 4.5. 4.5 divided by 4. 4.5 divided by 4. It is nothing but, I think, 1.125 maybe. 4.5 divided by 4, 1.125. Yes, 1.125 is the average value. Clear? 1.125 is the average value. Fine? Okay. Now next is average power. Average power, then energy of x of t of one cycle. Energy of x of t of one cycle divided by the fundamental time period. Divided by the fundamental time period. Clear? So here energy. So energy of this triangle function. So a square into width divided by 3. So one amplitude is 1, width is 1. So 1 into 1 divided by 3, plus energy of this rectangle function, a square into t. So 1 into 1 plus energy of rectangle function, a square into width. A is 3, guys. So 3 square, that is 9, width is 1, whole divided by the fundamental time period. Fundamental time period is 4. So it is 10 plus 1 by 3. So 10.33 divided by 4. Yes or no? Tell me. Correct? So 10.33 divided by 4. Calculate this. 10.33 divided by 4. 2.5825. Correct? 2.5825 watt. So this is the average power. Again, if you calculate the total energy, then the total energy will be what? Total energy will be infinite. If you calculate the RMS value will be square root of average power. So square root of this 2.5825, square root of this 2.5825, 1.61 or 607. The RMS value 1.607. And if you again calculate the total energy, then the total energy will be infinite, as this is the periodic signal. Is this clear to each and everyone? Tell me in the comment box. Clear, guys? Okay, so let us take next question. If it is clear, then now find the average power. Okay, again you can see the here fundamental time period. See the fundamental time period. You can say -1 to 1. So the fundamental time period is 2 seconds. What is the total energy? So energy of negative half cycle is equal to what is the total power? So total area. Area of positive half cycle is equal to area of negative half cycle. Here height 1, width 1, height 1, width 1. So total area is 0, average value 0, mean value 0, DC value 0. Now calculate directly average power. Average power or power. here average or mean or DC is 0, clear? Second, average power. So energy of one cycle. So energy of negative cycle, peak value square into width divided by 3. So it is 1 by 3 plus again here peak value square into width divided by 3. So it is 1 by 3 and total power is total width is fundamental time period is 2. So it is nothing but 1 by 3, correct? It is 1 by 3, guys. So what is the RMS value? RMS value is nothing but square root of average power. It is 1 upon root 3 and total energy is infinite. Again, total energy will be infinite. Clear to each and every one? Okay, next. Okay, now aperiodic signal. So conclusion is what? All the periodic signals are power signals and you will get the finite power and infinite energy, guys. And all the power signals are infinite duration signal. Clear? Now let us find the power of certain infinite duration aperiodic signal. Infinite duration aperiodic signal. Okay. Now this is the DC, guys. Constant DC. It is constant value for all t. A. Now, what is the formula to calculate power for the aperiodic signal? This is the aperiodic signal. So, average power of aperiodic signal is given by limit t tends to infinite 1 by 2t integration from minus t to t mod x of t. If it is a complex value signal, then you have to take the magnitude, but this is the real value. Okay. Now limit t tends to infinite 1 upon 2t integration minus t to t. X of t is nothing but a, so square of a is a square dt. It will be limit t tends to infinite 1 by 2t. Here a square, this is t minus t2 plus t. So the average power is a square. So what is the power of DC? That is the square of that value. Average power of DC is nothing but it's a square of that DC value, a square. And average power of AC is nothing but what? A square by 2, peak value square by 2. Okay. Suppose if x of t is equal to minus 5, then what is its average power? Average power is nothing but minus 5 square, which is nothing but 25 watt. Done. Average power is 25. So power of DC is nothing but square of that DC value. Now let us calculate the power of A into U of t, step function having an amplitude A into U of t. A into U of t. Amplitude is A. Clear? Again, this is also aperiodic signal. So average power of aperiodic signal is given by again limit t tends to infinite 1 by 2t integration minus t to t. Now square of this signal, so square of this signal is nothing but a square into u square of t dt. Now u square of t is nothing but u of t, and if you replace u of t with 1, then the limit will be 0 to t. So the average power is given by limit t tends to infinite 1 by 2t. Here if you replace u square of t with 1, then the limit will be 0 to capital T. The average power limit t tends to infinite 1 by 2t. Here this is a square and integration t, so it is a square by 2. So average power of u of t function is a square by 2, guys. Clear? The conclusion is power of u of t signal is 1 by 2. Yes or no? 1 by 2. A equal to 1. Step function, unit step function is 1 by 2. And if you do the folding with respect to y-axis time reversal, so already I told you power is directly proportional to square of the amplitude. Power does not depends on the width of the given signal. So time scaling, time reversal, time shifting operation doesn't alter power of the given signal. So that's why here average power remains same, 1 by 2. Clear? 1 by 2 guys. Done? Average power is 1 by 2. I hope all the students are getting. Any doubt? If you have any doubt, then you can ask in the comment box. Next. Now this is interesting part. Find the power of following signals. Power of the following signal. See, already we have seen the energy of this step function is infinite. Do you remember what is the energy of unit step function? Infinite, guys. What is the energy of DC? Infinite. But we got power finite. Now suppose this is the question exponential decreasing function, and we want to calculate the average power of this exponential decreasing function. Okay, this amplitude is 1, this is 0. What is the energy of this signal? Exponential decreasing function. So energy of this exponential decreasing function is nothing but 1 upon 2a, which is less than finite. That is finite. So energy of this exponential decreasing function is finite because this is another signal. Now let us calculate the power of this signal. So again, this is also, guys, it's a aperiodic signal. Correct? It's a aperiodic signal. That's why limit t tends to infinite 1 by 2t integration minus t2 plus t. Square of this function, so e power minus 2at, and this is u square of t dt. U square of t dt. Again, if you replace u square of t with 1, zero to t e to the power minus 2at dt. Okay, limit will be 0 to t. So the average power is given by limit t tends to infinite 1 by 2t. Here e to the power minus 2at divided by minus 2a limit is 0 to t. Then average power is equal to limit t tends to infinite 1 by 2t, here 1 minus e to the power minus 2a capital T divided by 2a. Now apply limit, guys. If you apply limit, then here see 1 minus 1 upon 2 into infinite, here it is 1 minus e power minus infinite divided by 2a. So it is 0, guys, because this will be finite. This is the 1 by 2a, 1 upon 2a, but it is 1 by infinite, so that's why it will be 0, guys. So average power is 0. If energy is finite, then here average power is what? 0, guys. Okay, so energy signal has 0 average power. Energy signal 0 average power, guys. Okay, so if the signal is energy signal, then energy will be finite and power will be 0. And the signal is power signal, then power will be finite and energy will be infinite. Power signal requires infinite energy and energy signal has 0 power. This is the very much important conclusion that you have to remember. Correct? Certain signals are there which are neither energy nor power signal. Neither energy nor power signal. Is this clear to each and everyone? Again same thing, if it is exponential decreasing function left hand side, then energy will be 1 upon 2a and again power will be 0. Any doubt in this? Now see, this is the exponential increasing function. Exponential increasing function, what will be the energy? So energy of exponential increasing function is infinite. Okay, this is exponential increasing function. So energy is infinite. Energy is infinite. Okay, now what about the average power? As I told you, if it is increasing function, whether it is right side increasing, left side increasing, energy will be infinite. So average power, again aperiodic signal, so limit t tends to infinite 1 by 2t integration minus t to plus t x square of t dt, limit t tends to infinite 1 by 2t, here right sided signal, so that's why 0 to t square e to the power 60 dt. Average power is given by limit t tends to infinite 1 upon 2t, here e to the power 60 divided by 6, limit is 0 to t, limit t tends to infinite 1 by 2t, here 1 minus 6 capital T e to the power 6 into capital T minus 1 divided by 6. Now if you apply limit, then it will be the infinite by infinite form. So you have to use the L'Hospital rule, correct? If you apply the limit, then e power infinite and here also infinite. So use the L'Hospital rule. So according to the L'Hospital rule, differentiation of numerator and differentiation of denominator, then apply the limit. So differentiation of numerator 6 e power 60, differentiation of 0 and differentiation of denominator, so differentiation of 2t is 2, guys, so it will be 12. Apply limit. So if you apply limit, now in this case the average power is infinite. So this is what energy also infinite and power also infinite. So if it is increasing function, infinite duration increasing function, whether it is right sided, left sided or both sided, if it is the increasing function, infinite duration increasing function, then energy also infinite, power also infinite. It is known as neither energy nor power signal. This is known as what? Neither energy nor power signal, guys. Power also infinite, energy also infinite. We got the power also infinite and energy also infinite. So it is known as what? Neither energy nor power signal. Neither energy nor power signal. Clear? Neither energy nor power signal. Yes, test series will come. Yes, we have test series, but I think we'll launch later. In I think August, September maybe we will launch. But yes, we have test series also. Manoj, yes, of course we have test series. The video lectures also. You can purchase. We can purchase weekly test also available in the paid class. Okay. Weekly test also available in the paid class. In the paid class, you will get DPPs also. For each and every class, you will get the DPPs. Your weekly test also available. Okay. Okay. So guys, in this way we can calculate power of the periodic signal as well as aperiodic signal. More questions are there. There are so many questions. Again, see, this is also, guys, see calculation of energy and power of the signal. So ramp function is nothing but t into u of t. So again, this is also infinite duration increasing function, right sided. Infinite duration increasing function. Infinite duration increasing function, correct? So here, if you calculate energy, then energy of this signal will be infinite, as well as average power will also infinite. So that's why this is also neither energy nor power signal. Neither energy nor power signal. Okay, clear to each and everyone? So guys, let us finish this lecture here. In next class we will solve more questions based on this also. Okay, like u of n in discrete time. You will find the power of discrete time signals. Okay, so there are, I think, 1 2 3 4 5 6 7 8 10 10 to 15 questions are 10 to 12 questions are that, but we will solve in the next class. Okay, so all of you, thank you so much watching me live on Wallah English channel, and please okay, and please provide your valuable feedback after completion of this session, and next part we will continue into subsequent module. Thank you guys, thank you.